Hello everyone, and welcome back to Test Equipment Chronicles with Bob. I'm Bob Brown. Today I want to take you through a story that, in my opinion, is worth telling, right? This is not just a story about emissions testing. It is not just a story about policy. And it is not just a story about technology. It is really a story about what happens when an entire service industry gets pushed into change and then rises to meet it. I had a front row seat to that process here in Wisconsin. I saw it from the technician side, I saw it from the training side, I saw it from the equipment side, and later I saw it from the oversight and policy side. So what I want to do in this episode is walk you through that evolution, starting back in the early days when all we were hearing were rumors about tailpipe testing. And most technicians really did not know what was coming next. There was a lot of skepticism, there was a lot of misunderstanding. And yes, there was a fair amount of doom and gloom. But there was also opportunity. And over time, what I saw was this. Education did more to clean up the air than all the noise, all the politics, and all the heavy-handed talk ever could. Because at the end of the day, if the hood does not get opened and a skilled technician does not repair the vehicle correctly, nothing gets fixed. And that is really the theme of this whole podcast. It really started for me back in that 1982, 1983 time period when the rumors first began floating around that Wisconsin was going to go to tailpipe emissions testing. At that point, there was a lot more rumor than fact. Most of what we thought we knew was coming out of California, and for a lot of technicians in the Midwest, that felt pretty far removed from what we were doing day to day in the service bay. There was a fair amount of doom and gloom. There always is when change is coming. You heard plenty of talk like, oh, well, I'm not going to fool with that, or that's it, I'm getting out of the business, and so on. A lot of technicians saw it as one more government headache, one more thing coming down on the trade, and they were not entirely wrong to be cautious. At the time, the understanding just was not there, but on the other side of it, a number of us looked at it differently. We saw it as an opportunity. One of the hardest things in the repair business has always been getting the customer to stand still long enough to fix the car properly. A customer can drive around with a rough, idle, poor fuel economy, a lazy carburetor, a weak ignition system, and as long as it still starts most mornings, they often just keep going. That was true then, and in many ways it is still true now. With emissions testing coming, all of a sudden there was a reason the vehicle had to be repaired correctly. Now, I'm not saying people liked spending the money. I sure didn't then, and I don't now. But I have always believed that doing something the right way is usually the cheapest way in the long run. I used to laugh about this, and there is a lot of truth in it. You cannot get by doing your plumbing halfway, your wiring halfway, or your heating system halfway, but somehow people think they can do their vehicle halfway. I have watched that my whole career. For whatever reason, the automobile gets treated differently than almost any other technical system people own. So when the state started ramping up, one of the first things they did was begin putting classes together. Early on, those classes were introductory in nature. What is emissions testing? What are we actually measuring? What is carbon monoxide? What are hydrocarbons? How does a gas analyzer work? What are these numbers trying to tell us about combustion quality? I happened to be in a pretty good spot at that time because through Sun Electric, this was already part of the world I was working in. Sun had been in engine analysis and gas analysis for a long time, and they made some very fine equipment. Their training material was solid. It was practical, it was technical, and it helped bridge the gap between the machine and what the technician had to do with the information. So I started out attending those classes, learning right along with everyone else. Then before too long, I was presenting and teaching some of that material myself. I was pretty young at the time, both in age and in the industry, but I was also very fortunate. I had a good learning period, and I was around some very capable people. And I will tell you something else. Looking back on it now, I probably thought I understood more than I really did. That seems to be one of the great gifts of youth. Once we got into the actual nuts and bolts of emissions diagnosis, the whole thing became a lot more interesting. Most of those early vehicles were carbureted, so now the technician had to stop being just a tune-up man or parts changer and start becoming more of a diagnostician. You had to understand what the tailpipe was telling you. One of the ways I learned to think about it, and one of the ways I often explained it, was kind of like a teeter-totter relationship between hydrocarbons and carbon monoxide. Not perfectly, because there were exceptions, but often enough to be useful. If you brought the CO down, the hydrocarbons would tend to rise. If you brought the hydrocarbons down, the CO might climb. That balance mattered. A rich running engine, generally speaking, is a smooth running engine. That is one of the traps. A technician would look at a vehicle that ran nice and smooth and think, well, this thing can't be too far off. But then the gas analyzer would tell a different story. The CO would be high, the engine would be rich, and now if the technician simply leaned the carburetor out to lower the CO, very often the hydrocarbons would jump because the engine started misfiring. So now the problem was not just adjustment, it was understanding combustion. That was one of the great values of the training. It forced technicians to think beyond the old seat-of-the-pants method alone. Now, I still believe in seat-of-the-pants diagnostics. I really do. Sitting in the vehicle, putting it in gear, feeling the smoothness of the idle, listening to the exhaust cadence, sensing how the engine carried itself under load, that told you a lot. In many ways, that was still one of the quickest indicators of what kind of tailpipe numbers you were likely to see. But emissions work demanded another level. You had to connect what you felt, what you heard, and what you measured. I remember Larry Slaughter from Iowa coming in and teaching classes on carburetor setup and fine-tuning. I enjoyed those classes immensely. You learned how to tune for performance, yes, but you also learned how to tune for clean combustion. And that was a very different discipline. It helped solve emissions problems, and truth be told, it did not hurt your understanding of race engines either. Not that I was doing anything questionable with my 440 CUDA or 429 Torino and the like. We're, of course, all law-abiding citizens. What started to happen in those years was actually pretty remarkable. The industry began to improve. Technicians who may have been skeptical at first started getting at diagnosis. Shops started investing in gas analyzers. Repair decisions became more informed. Instead of guessing, technicians had data. Instead of just saying, it seems a little rich, they could prove it. Instead of blaming everything on the carburetor, they began to understand ignition quality, vacuum leaks, mixture control, combustion efficiency, and the interaction between all of those systems. And that is really where the story begins, because the early tailpipe era was not just about measuring pollution. It was about forcing the service industry to sharpen up. It pushed a whole generation of technicians to become more analytical, more disciplined, and more educated. In my view, that was one of the biggest wins of the whole program. The car got cleaner, yes, but the technician got better too. And once that foundation was laid, then we were ready for the next phase. The next phase was going to be a much bigger jump, because going from a gas analyzer in the tailpipe to IM240 was not just another step. It was a whole different level of science, policy, equipment, and technician adaptation, and that is where things really started to get interesting. As we moved out of the early tailpipe era and into the late 1980s and early 1990s, you could feel the next wave coming. At first, it was more rumor than reality, just like it had been back in the beginning. We started hearing about enhanced testing, transient testing, dynamometers, federal test procedure ideas, and this thing called IM240. For most technicians, and frankly for a lot of administrators too, that was a whole different language. This was round two of poor understanding. Only this time, the science was a whole lot heavier. With the early tailpipe testing, at least you could wrap your mind around the concept pretty quickly. Probe in the tailpipe, look at CO, look at hydrocarbons, make your adjustments, solve the combustion problem, and move on. IM-240 was a very different animal. Now you were talking about putting the vehicle on a dynamometer, running it through a transient drive cycle, collecting the emissions output in a much more engineered way, and converting that into grams per mile. That is a big leap. That is not just tune the carburetor a little better. That is moving from a service bay mentality towards something that looked much more like an engineering lab. And that made people nervous. I was involved in a long series of meetings in Milwaukee during that period. Early on, those meetings were held monthly, and they went on for years. And that was really where a lot of the practical discussion took place. The board, the state people, the technical people, the vendor side, and those of us trying to represent the repair industry all had to start sorting out what this was actually going to mean in the real world. That is where I had a chance to work with some very talented people in Wisconsin. Jerry Miniger was one of them. Chuck Rhodes, who ran the program, was another extremely capable man. And Muhammad Islam from the DNR did a lot of the analytical work. Those were three of the main people I interacted with, and I want to make that point clearly. Wisconsin was fortunate. We had people who were willing to learn, willing to listen, and willing to work through the problem. That was not true everywhere. One of the things I respected about Wisconsin was that even when there was disagreement, and there certainly was, the discussion was usually aimed at trying to get the thing to work. Not just checking a box, not just satisfying some policy memo, actually making the program function in a way that would clean up the air and still be repairable in the field. Because that was always my concern. If the hood does not get opened and a skilled technician does not repair the vehicle, nothing gets fixed. I did not care how elegant the policy sounded. I did not care how impressive the charts looked. If the vehicle failed the test and then nobody could diagnose and repair it in a practical, affordable, repeatable way, then the whole thing was going to fall apart. That became one of my central themes all through the IM-240 era. And I was probably a little stubborn on that point. Actually, no, I was very stubborn on that point. At the same time all of this was going on in Wisconsin, I was attending the National Clean Air Conferences out in Colorado. Those conferences were an education in themselves, usually 3 days, often held in places like Breckenridge, Vail, Colorado Springs, Steamboat Springs, nice settings, kind of swanky if we are being honest, but they brought together a very wide range of people. State officials, EPA representatives, technical specialists, vendors, engineers, policy people, and others tied into emissions programs from around the country. And what you saw there was two very different worlds. On one side you had some incredibly sharp technical people, I mean brilliant people. The engineering talent was off the chart. The people from Ann Arbor, the EPA lab people, the vendor engineers, the specialists who understood full volume sampling, transient cycles, grams per mile calculations, evaporative systems, catalyst efficiency, all of it. That side of the room was fascinating to me. I was mesmerized by it. I truly was. By the time I had gone to enough of those conferences, I felt like I could have comfortably worked around an FTP style lab environment and understood what was going on. Not because I was some great wizard, but because the training was that deep if you paid attention. But then there was the other side of it, the bureaucratic side. Now, I do not mean that as a cheap shot, it is just the truth. There were many administrative people, especially from outside Wisconsin, who had almost no real appreciation for what it took to turn a failed test result into a repaired car. They understood budgets, deadlines, mandates, grant money, enforcement structures, policy schedules, and administrative language. What they often did not understand was the technician. And that bothered me. It bothered me a lot because there was in too many places a very poor opinion of service technicians, almost a dismissive attitude, as if the technician was some problem to be managed rather than the very person who was going to make the air cleaner. That is backwards thinking, completely backwards. The technician is the one who opens the hood. The technician is the one who diagnoses the failure. The technician is the one who installs the part, verifies the repair, road tests the vehicle, and gets it through the program. If you build a whole emissions strategy around contempt for the repair industry, then you have already made a major mistake. Wisconsin, to its credit, generally did not do that. Other places absolutely did. And I do not need to name names. Most people can imagine the kind of environment I'm talking about. Heavy-handed, enforcement first, big hammer, big government. You will do what you are told approach. That rubbed me the wrong way then, and it still rubs me the wrong way now. We were not there to debate whether the law existed. It existed. The question was, how are we going to implement it in a way that actually solves the problem? That is a very different mindset. Wisconsin used more carrot than stick. We put real effort into technician training, real effort into outreach, real effort into making the program understandable. Not perfect, but serious effort. And the reason that mattered is because when you train technicians properly, three good things happen all at once. The vehicle gets repaired. The cost to the consumer usually comes down because diagnosis improves. And the technician gains skill and earning power. That is a win-win-win. And that was the bridge I kept trying to build between policy and practice, between administration and repair, between what looked good in a conference room and what actually worked in a service bay. Now, from a pure testing standpoint, IM240 was impressive. There is no other way to say it. It was performance-based. The vehicle either made it through the cycle cleanly or it did not. End of story. And there was something I liked about that. You could take a modified vehicle, a pickup, a performance car, something with aftermarket fuel injection, intake work, headers, whatever the case may be, and if it ran clean enough to pass the IM240, then it passed. That was a very straightforward concept. The car was either clean or it was not. I appreciated that because it put the emphasis on actual measured outcome. At the same time, though, it created a practical challenge for the service industry. How do you take something as complex as a transient test that was born out of an engineering environment and convert it into a repair pathway that ordinary technicians can follow? That was the million-dollar question. That is where the meetings in Milwaukee mattered. That is where the clean air conferences mattered. That is where all the crossover between the technical side and the field side mattered. Because somebody had to translate. Somebody had to say, all right, this is what the test is doing. This is what it is trying to expose. This is why the vehicle failed. And this is what the technician needs to look at when that vehicle comes into the shop. That translation layer was thin. Not non-existent, but thin. And I spent a lot of time living in that layer. That was really the heart of the job. Not just policy oversight, not just sitting in meetings, but helping bridge the gap between the vendor, the state, the technical assistance people, the educators, and the repair shops that had to make this thing work every day. And I will say this too. Those years taught me a lesson that still applies today. If you want to solve a technical problem in the real world, you had better respect the people who actually do the work. If you build your whole approach around politics, posturing, and punishment, you may make headlines, but you will not fix much. If you build it around education, training, cooperation, and practical skill, you have a fighting chance. Wisconsin, in my opinion, proved that. Now eventually, of course, the next phase started coming into view, and that was OBD2. In some ways it made life easier, in some ways it made life more complicated, because now the car itself was beginning to tell you what it thought was wrong. And that changed the whole game all over again. As we moved into the OBD2 era, the whole tone of emissions diagnosis started to change again. On the surface, it looked like life ought to get easier, and in some ways it did. Now the vehicle already had diagnostics on board. Instead of relying entirely on an external test system to tell you whether the vehicle was clean, the car itself was monitoring major systems and reporting faults. For a technician, that was a major shift. You were no longer starting from scratch with just a symptom, a tailpipe number, or an IM240 failure profile. Now you had onboard information, fault logic, monitor status, and a much more direct path into the system. But that did not mean it became simple. Not at all, it just became difficult in a different way. With IM240, the test was performance-based. The vehicle either went through the drive cycle cleanly or it did not. That was one of the elegant parts of that system. If a car had been modified, whether it was a sports car, pickup truck, or something with aftermarket fuel injection, headers, intake changes, whatever the case might be, if that vehicle ran clean enough through the test, it passed. End of story. The machine was looking at the result. OBD2 changed the conversation. Now you are dealing not only with whether the vehicle ran clean, but whether the onboard system believed everything had been tested, verified, and completed according to its own internal logic. So now you had this whole added world of readiness monitors. And that is where a lot of technicians got their next education, because setting readiness monitors was not just a clerical task. It was not just clear the codes and send it. You had to put the vehicle through a very specific operating pattern to get those monitors to run. Catalyst monitor, EGR monitor, purge monitor, EVAP monitor, oxygen sensor monitor. All of those systems had to see the conditions they needed before the vehicle would declare itself ready. So in a strange way, the post-repair drive cycle became its own miniature test procedure. Not an FTP in the full lab sense, not an IM240 in the formal lane test sense, but it absolutely had that same flavor. You had to understand load, speed, temperature, steady cruise, cold start logic, and all the little conditions that would either let the monitor run or keep it from running. And if you did not understand that, you could fix the vehicle correctly and still not get it through the program. It was a new frustration. Now, one of the good things with OBD2 was that the capital expense for the shops was generally lower. You did not need to buy the same kind of gas analysis equipment. You did not need the large investment that some had made around emissions, specific analyzers, or portable IM240 style support equipment. Technicians already had scan tools or were moving in that direction. So in that sense, the barrier to entry looked better. But again, that did not mean it was easier. It meant the challenge had moved. And in my opinion, one of the biggest headaches of the whole OBD2 era was EVAP. Anybody that works in the field knows exactly what I am talking about. EVAP problems have caused more grief than they had any right to. Leaks, valves, purge flow, vent problems, canister issues, monitor refusal, intermittent faults, borderline failures, software sensitivity, all of it. There were plenty of cases where the vehicle was not really broken in the way the customer would understand it. It ran fine, drove fine, started fine, fuel economy might even be decent, but the monitor would not set, or a code would come back, or a small leak logic would keep it from completing. That was maddening. And it is still maddening. Sometimes the cause truly was a component issue. Sometimes it was an underperforming system that needed proper diagnosis. And sometimes, if we are honest, it was a matter of software calibration, aging hardware, and manufacturer strategy not keeping pace with what those older vehicles were becoming out in the real world. That created a different kind of burden for the technician. You were no longer just fixing combustion quality or correcting an emissions output failure. Now you were working in a cat and mouse environment between the actual hardware on the vehicle and the logic the manufacturer had written into the monitor strategy. And those are not always the same thing. That is an important distinction. by that point, Wisconsin had also put real effort into supporting the repair side of the business. The technical assistance centers mattered. Having highly trained people available to help guide difficult cases mattered. WiseTech certification mattered because now labor and parts used by qualified technicians could count toward the waiver structure, which gave the motorist a path and gave the repair industry a stronger role in the solution. That was important. Not all states handled it that way. Wisconsin did. And those emission service bulletins, the ESPs, mattered too. They helped technicians focus on patterns we were seeing in the field. That is real world value. That is how you take program data, field trends, and recurring failures and turn them into something useful for the people actually doing the repairs. That, to me, was always the right direction, because once again, the goal was not just to make rules, the goal was to fix cars. When I look back across all three phases, the early tailpipe era, the IM240 era, and then the OBD2 era, I see three very different ways of judging the same basic problem. Each one lived in a different technical domain. The early tailpipe test asked, what is coming out of the pipe right now? IM240 asked, Turagirel, how does this vehicle perform dynamically under a simulated driving load measured in a far more engineered way? And OBD2 asked, what does the vehicle itself know about the health and completion status of its emission systems? Those are not the same question. And that is why each testing phase required a different mindset from the technician. If you happen to live through all three eras, and I did, it was a fascinating ride. You saw the trade change, you saw the tools change, you saw the knowledge base expand, you saw technicians who had once been mostly mechanical become diagnosticians, then become systems thinkers, then become scan tool driven analysts who also had to understand software behavior, monitor logic, and manufacturer strategy. That is a tremendous evolution. And I do not think the trade gets enough credit for making that leap. Today, the vehicles are so clean compared to what we were dealing with back then that in many respects the old testing models have done their job. The manufacturers improved, the technicians improved. Policy, for all its faults, did force some needed changes, and the vehicles themselves became dramatically better. We arrived. That does not mean every policy was perfect. It does not mean every stakeholder was wise. It does not mean every state handled it correctly. Some did a poor job. Some took a far too heavy-handed approach. Some never really respected the repair community. I saw enough of that firsthand to know it was real. But Wisconsin overall showed that there was a better way. A cooperative way, a technician-centered way, an education-centered way. And that is really the heart of this whole story. Education won the war on pollution. Not by itself, of course. The manufacturers mattered. The policy people mattered. The data mattered. The public mattered. But when all is said and done, the air only got cleaner when somebody opened the hood, understood the failure, and repaired the vehicle correctly. That was true in the carburetor era. It was true in the IM240 era. And it was true in the OBD2 era. So when my own direct professional involvement started winding down in the early 2000s, I could look back on it and say this: it was worth doing. It really was. Not because it was always pleasant. Not because there was not friction. Not because there were not politics. There were plenty of politics. But because the positives outweighed the negatives. The cars ran better, they lasted longer, fuel economy improved, the technicians got better, and the air got cleaner. That is a pretty good legacy. And maybe the bigger lesson for today is this: when you have a hard problem, an adversarial environment, and a lot of competing interests, you still have a chance to get somewhere if you stay focused on the real objective. Respect the people who do the work and commit yourself to education instead of just punishment. So that is my look back at the history of emissions testing here in Wisconsin, from the early tailpipe era to IM 240 and then into OBD2. And when I look back on all of it, I still come to the same conclusion. The biggest win was not just cleaner air, it was better technicians, better training, better understanding, and a better chance of actually fixing the vehicle instead of just talking about it. There were politics, no doubt about that. There were disagreements, there were some rough edges, and there were a few things along the way that, if we knew then what we know now, we probably would have handled a little differently. But overall, I believe the positives outweighed the negatives by a wide margin. The vehicles ran better, they lasted longer, fuel economy improved, and the people in the trade rose to the occasion. If you enjoyed this type of long-form technical storytelling, make sure you subscribe to Test Equipment Chronicles with Bob. And if you know another technician, instructor, shop owner, or just somebody who appreciates the history of how this industry evolved, I would appreciate it if you would share the channel with them as well. Thanks very much for spending the time with me. I truly appreciate it. This is Bob Brown, and I will see you next time on Test Equipment Chronicles with Bob.